Okay, so this is general notes that you need to know for the vectors for being able to find the resultant. This also helps you find the magnitude and the vector, which we'll talk about a little bit later as we progress. So these are kind of like step-by-step process for you to have too, so if you want to pause and write this down, I found this helps a lot. First, we want to draw a picture. Second, we want to separate our components. So we want to determine the values of x and y, which are relative for our vectors. To do this, we are going to take the cosine of x and the sine of y. I know this may be confusing, but it will make more sense as we progress. Number 3 is after we do take the two different values for the components, when there's two vectors, we're going to combine them. So we'll combine our x values, combine our y values, and we will determine our magnitude, number 4, by using Pythagorean theorem. I'm not actually sure I spelled that right, which is awful pathetic if I didn't, seeing as I am a math teacher. Finally, we will determine the angle or the direction of a vector by using tangent raised to the -1 times the y divided by x value. So this is general steps, general ideas of what's going on, what we need to do. So we're just going to go on to the next slide. The second slide here tells us that, on a side note, if a vector is given to us in the form of meters per second, then the magnitude and velocity are the same, because that is talking about direction and speed. So number 1, it says to find the resultant of the following vectors. The vector A has a velocity of 50 meters per second, and it is 30 degrees north of due east. Vector B has a velocity of 30 meters per second at 60 degrees north of due east. So when we consider the coordinate grid of mathematical, we have north, never, eat, east, sour, south, watermelon, west. When we're looking at this and it says that it's 30 degrees north of due east means directly east. So if we look straight across directly east, and then we're going to go back up to north, and that creates our vector. So this one is in yellow. I'm hoping that you'll be able to see it. If not, we'll go back through it. But it is 30 degrees roughly, this is rough drawing, north of due east, and then we have the one in blue, which is 60 degrees north of due east. So we now have step 1 of our process completed. We have our picture done, and we want to go ahead and proceed to the process number 2, which was to separate the components. So we're going to start by separating x. Sorry, all those pictures were highlighted. So I just copied and pasted up here, so we still have our vector to refer to. And when we're looking at this x1, it told us that it was 50 meters per second for 30 degrees. So right here I have created x1 is equal to 50 cosine 30 degrees. When we are determining the math coordinates, so this was something that was a little bit confusing to me at first. When we're determining the degrees, we want to use the math coordinates, meaning when we look at a coordinate grid, it's labeled 1, 2, 3, 4 in regards to a C. It's not the same as we think of our direction. So we have 1, 2, 3, 4, meaning that when we label our degrees, we start here at 0, go to 90, 180, 270, 360, and it proceeds and it creates a circle, but it's counterclockwise versus clockwise. So that's where we got this 30 degrees from. So we have 50 cosine of 30 degrees. I just entered this into my calculator. If you don't have your scientific graphing calculator, just let me know and we can do it over the phone or whatever. And so that equaled roughly 43.3. Doing the same thing with the second one, x2 is what I was calling it, our second vector, which was really vector B, I believe. We did 30 cosine of 60 degrees, and it was equal to 15. Adding those together to combine them so that in a minute we'll be able to get our magnitude, we found 58.3 to be the combination of x values. Number 5, we're doing the same thing, but we're doing it with y. So I've just created another slide so we kind of break it up each time. When we're using y, we're going to do sine instead of cosine. So we're doing 50 sine of 30, 30 sine of 60. 50 sine of 30 was 25, 30 sine of 60 was 25.98. I think that 98 is kind of right outside the viewing area. and now I put it over the decimal. There you go. So that's roughly, it was kind of estimated, and when we add those together, they come together to give us 50.98, which is the combination of the y value for our different vectors. So what's going on here is when we have vectors, they're really on separate planes because we don't know necessarily, if we're considering three-dimensional, which direction they are heading, and if they're really not heading in the same direction, they're not going to be on the same plane. So that's why we have to take the trig version of it and combine it all together. So now we get to finding the magnitude. So I do have an r here because this is going to lead us to our reluctant, but really this is our magnitude, and this is where we use Pythagorean's theorem, where a squared plus b squared equals c squared. In this case, we're using x squared plus y squared equals r squared. I believe I have made an error. I think we need to take the square root of that. 77.45. Okay, so yeah, I did that right, I think. I would double check it in your calculator because at this time I'm a little delusional. But it should be roughly 77.45, which leads to give us the magnitude. Proceeding to find the angle, so we're going to go on to the next slide. This is to find the angle that we don't know, which is basically the angle that we've shown. I'm going to flip back really quick, so hopefully you don't get lost. But the angles that we have here, we have this 30-degree and this 60-degree angles. When we connect them, it's going to create another angle that we're looking for. And so to find that angle, we take the inverse of tangent with our y value divided by our x value. So this goes back to our combination of the y and the x, which was found slide 4, 6. So here we found the combination of x to be 58.3, so that's going to be our denominator. And here we found the combination of y to be 50.98, so that's going to be our numerator, which you can see right here. So we just plug that into the equation. Yet again, plug it into your scientific calculator. If you don't have one, I'll have one available when we talk later. So that angle is roughly 41.17 degrees. I should have little degrees there, sorry about that. And this gives us the direction of the new vector. So when we come together to get our reluctant, we find that the reluctant is 77.45 meters per second. Again, that's roughly. I don't know, you're going to have to see your notes how they want the rounding to be. And it is at 41.17 degrees, which makes sense because when we started this equation, we were in quadrant 1. So we want an angle and a degree that's going to be in quadrant 1. Hopefully this will give you a good start, and I will talk to you later.